Right, so what I'm going to be doing in this video is I'm going to try to show that the angle E1 to G1, E1 G1 and to this line here is always 90 degrees. So a line from the center to a tangent of a circle, that angle is always 90 degrees. Now it's going to look like 90 degrees, isn't it? But we need to kind of prove it. But let's just use our tool here to measure it. So we're going to click on that line, then we're going to click on that line, and yeah, 90 degrees, no problem there. Let's actually measure this 90 degrees, but as you can see, that's 90 degrees, then that must be 90 degrees as well. Maybe if I do it the other way around, let's see what happens then. Oh, for some reason, it just wants to do that. Well, okay, that's fine. Anyway, so that's 90 degrees. So how can we prove that that must be 90 degrees? Well, the way to do that is by drawing some other lines. So I'm going to I need to pick another line. What do I want? Let's pick a segment, I think. I'm going to draw a line from here to here. And I'm going to draw a line from here to here. I'm going to just pick one of these triangles. Let's pick the one on the right. So E1, H1, G1. You can see that, well, first of all, we know, okay, hang on a second. Let's think about this. So basically what we're going to say is we're going to pretend that we don't know that is we're going to pretend that we don't know that that's 90 degrees. So I'm going to just delete that angle there so we can't see it. Oh, I've done two of them, haven't I? And of course, this line here can be anywhere, right? So if that's not 90 degrees in this hypothetical reality, then we're going to pretend that this is 90 degrees. So this could be anywhere, couldn't it? And or it could be the other one on the other side. So if that isn't 90 degrees and that isn't 90 degrees, then there would be an angle either side of this that would be 90 degrees. So it doesn't matter which way around we do. Let's just pick. I don't know. You can move the letters around. That's quite handy. Let's move this one down here then. I will say that let's pretend that's 90 degrees. So now if that was 90 degrees, let's just redraw it as it would look. It clearly doesn't look 90 degrees, so it's a bit of a difficult proof to visualize. But what I'm saying is well, and it's, as I say, it's very difficult to visualize this because it clearly isn't 90 degrees. But I'm taking the situation that maybe it is, and we're going to imagine that was the case. Now, if that was the case, then the longest side of the triangle would be E1, G1. And you can see that it isn't, is it? It's because you can see on this diagram here that E1 to H1 is longer than E1 to G1. How can we see that? Well, because E1 to this end here, that's the circumference the radius of the circle. E1 to G1 is also the radius of the circle. So I can actually in fact, what I can do is I can move this. Oh, great. That's not what I wanted to do. I'm just going to see if I can undo that. Can I undo that? Yes. I'm going to put another point here. It's possible. I don't know how to get this exactly right. There probably is a way. It looks like it automatically makes it exactly right. Anyway, so I've added a point J1 there, and I think there should be a way of measuring this. So if I do that, 11.3, and and the other one will also be 11.3, won't it? So there you can see they're both 11.3. So because that's the radius of the circle, so I'm just going to get rid of that one on the middle one. They're both, the radius of the circle is 11.3. If I went from any 2 points, it's going to be 11.3. I wonder if I can actually measure without actually drawing a line. I think I can. Let's just give it a go. Distance, let's go from E1 to just the side there. Yeah. Oh, okay. That's the circumference. All right. Fair enough then. Don't really need that. Okay. Anyway, the distance from E1 to J1 is 11.3, and we just showed the distance from E1 to G1 is also 11.3 because that's the radius of the circle. And if that's the case, then this isn't the longest side. This couldn't be the longest side. Doesn't matter where I put. Let's try that again. Doesn't matter where I put H1. It's always going to be the longest side, and it's only until I get it to equal to G1 that it's a shorter side. Up until that point, it's always going to be longer, and so that would have to be a hypotenuse if it was a right angle triangle, and this angle could never be 90 degrees. It would have to be, if we were doing a right angle triangle, it would have to be this angle here. So that's the proof of that circle theorem.